Hello, my name is Samuel Bernardini, and this is my presentation about lion hunting patterns around distinctive land features in the Serengeti. This is for the Bio 182 Lab section presentation assignment. So, for our introduction, when we were posed with this assignment and getting a question, most of the topics were about the prey animals, but we wanted to look into the predator animals and according or with the data set that we were given, the only predator we had access to were lions. So one of the questions we came up with was, do lions hunt more in certain areas? Because we thought about how, in the Serengeti, especially during dry seasons, there's not a lot of areas, to get water, and that could make a good hunting place for lions. So one of the hypotheses we came up with is if the lion risk factor, which is a data stat we'll get into later in the presentation, is higher in a certain area, then a distinctive land feature must be nearby. And we came up with multiple land features. Specifically, as you can see in the images, we have a river. More specifically, this is a confluence of a river. So this is a meeting between two rivers, and a kopja, which is like a hilly area in the middle of some plains that lions do like to rest upon. So one of our predictions were that lions can gain a height advantage from kopjas, therefore will be more of a risk to prey, and risk near rivers would be lower during wet seasons since there would be more sources of water. There would be less likely chances of a bunch of animals hanging around rivers. So maybe they'll be more spread out, and the risk would be lower to a certain degree. Now, our methods of going about finding this data and going about um, reading the data and getting results and discussions from the data. One of the methods we used two pieces of software. We used Microsoft Excel, which most people know as a database, a data entry tool. It can make graphs, but we used Excel to get a basic understanding of the data, and we used a program called JMP or Jump. Jump is better suited for graphing large data sets, and this data set we have is a collection of trail cam footage, or rather pictures, from the Serengeti, and it has about 700,000 individual sets of data. So using JMP is definitely a preferred method of using or getting graphs from this. So the main like data points we wanted to use were, looking for lion risk during dry and wet seasons. Those are two individual data points. You can see how we would make the graphs in the top left image. It's a graph builder. You can basically set any variable against another variable. You can do this multiple times for the same variable against different variables. And the other data points we looked for were distances from the cameras to certain land features like the aforementioned kopjas and rivers and river confluences, because those are two separate data points. So we made graphs for each one. The results we got were both negative correlations from lion risk, dry and wet. The top graph shows wet and dry versus distance to kopja, and the bottom one shows wet and dry versus distance to a river and distance to a confluence. They're both negative correlations, so the closer they were to the certain land feature, the higher the risk. And we'll go over that in this next section. So for the discussion section, we do have some limitations. The cameras are stationary, they cannot be moved. We have environmental factors like natural disasters, like fires and stuff. Time of day is a big factor as well. You do have to worry about that. When you get pictures, it could be really dark. Not all the pictures that were gained from the trail cams were not, they didn't show much. They didn't show anything if it was like nighttime or if it was covered by brush or something. That is one of the major limitations of this. So, kind of a big. We're going purely off of data points and not actually like any conventional like going out and finding anything. So the findings themselves, both graphs, like I said before, showed negative correlations. So the closer the camera was to one of these landmarks, the higher the line risk was, both during wet and dry seasons. And the river comparison shows a decrease in risk during wet seasons, like one of our predictions said at the beginning, because, animals don't need to huddle around rivers the whole time for their only source of water. And kopjas, we assume, could be used potentially for scouting advantages for lions because it gives them a high point of view over giant flat land, which also could increase the risk. So here are my citations. All of the photos we used were from the Serengeti National Park website, the two at the beginning, and these are all the primary literature that was used in developing these hypotheses, questions, and predictions. Thank you so much.